My name is Daniel Figuier. This is Nate Kolbeck. We started a company called 3D Brooklyn. We do 3D printing and prototyping in Brooklyn, New York. I have a video I was going to show you guys really quick. It's just 1 minute, just to give you an idea of kind of how crazy we are and what we do. And then we can get into more of the specifics in a second.
Welcome to 3D Brooklyn, where you can make your ideas into reality. We partner with innovators to design and build new products that inspire, educate, and empower us. Our mission is to enable you to make something amazing. We know this because we're just like you, creating with everyone from agencies, startups, entrepreneurs, and artists. We bridge the gap between you and the digital manufacturing technologies shaping our world. And we work with you step by step. We believe access to technology is a human right, and we're all created by nature.
All right, so that kind of gives you a quick visual of what the world of 3D printing is like. Does anyone here have any experience with 3D printers or anything? You know about 3D printing? You guys? Okay, cool. So we understand the technologies, the plastic printing and everything. All right, awesome. So just a little bit about myself. I come from the film industry. I got inspired by 3D printing by traveling around with a bunch of celebrities around the globe. And they were the chief creative officers for a bunch of corporations at the time when it was very popular. And Nate and myself would do documentaries on these celebrities and get access to boardrooms where you would see new products that haven't come out yet, and they would talk about to the celebrities like how they needed to keep promoting these and getting them out. Through that, we actually got in touch with 3D Systems and worked with them for a couple of years when they were getting into consumer 3D printing. Do you want to touch on that at all?
Well, does everybody know who 3D Systems is, the company, and Stratasys? And sort of they're the two big patent holders in the industry. Yeah, so we got in with them. They're about halfway through their consumer push that ultimately failed, and they're pulling out of consumer entirely. Both companies, well, Stratasys is still in with the MakerBot product, but at the time they really believed in the consumer market for 3D printers. So it was at the peak of the hype cycle, basically.
Yeah, so what we did at that point is we took our film background and applied it to the 3D printing world, basically, and gave it the non-engineering sort of background, right? We saw the technology in the film industry when the digital camera hit it, and it exploded onto the film industry at first and TV industry. And then eventually the red camera became extremely big and kind of took over the whole market, right? And now you have all the rest of them coming out now. We saw that happen in the film industry and immediately jumped to 3D printing as a platform, knowing that it would do the same thing. So we've been in it for about 2 or 3 years, kind of going on to our 3rd year now. So we focus on local 3D printing, CAD design, prototyping services for people in Brooklyn and really the kind of tri-state area. We do work globally with a bunch of brands and corporations, but we focus intently on local manufacturing. And today our talk is about factories of the future. Can we manufacture on our own? That was the name of our talk. So do you guys know of a website called 3D Hubs? No? 3D Hubs is like the Airbnb of 3D printing. You basically can rent anyone's printer who has it in one of these areas. They all have various technologies from powdered nylon to resin, high resolution resin, to cheap plastic printing. And they tout a very high sort of penetration to the market. They're saying this is now up to 1 billion people have access to 3D printing. And the turnaround time for printing with this service is around 48 hours, right? So it's actually relatively quick already. And just to kind of answer the first question, can we manufacture on our own? Yes, like it's happening at a global scale already. and people are opening up new 3D hubs probably, I mean, daily at this point. But they're really, right now the business is really focused on industrial manufacturing. This is just their website. I just wanted to show you guys. It's very easy to go on there and just kind of get started. A similar sort of structure of a business to ours, where they do the quick printing, they just focus on getting people their prints. We focus more on prototyping, so I'm going to be showing a couple other companies that are similar to us, just so you get an idea of what the industry's like. And then we are all digital creatives. Do you want to kind of take it from here?
Sure, yeah. We just want to talk about today, we had a customer, or actually a journalist come in the other day, and she was interviewing me and asked me a question I haven't been asked in a while, which is what's different? You know, like 3D printing was going to change the world a few years ago, then all of a sudden it went away and puttered out, and what's different now? It's not an easy answer. There's a lot of different reasons that it's different, but I just started jotting down, a couple ideas with her, and the first one is the idea that we're all digital natives. Every single one of us in this room has a computer in our pocket. We pull it out 50, 60, 100 times a day. We're all very used to the infrastructure that's been built over the last 20, 30 years, computers, mobile phones, the internet, the cloud, and all of these things are powered by our digital skill sets. So when you talk about digital manufacturing, it's completely different than traditional manufacturing. You don't need to study under a woodworker in order to create objects anymore. You just can jump on a computer and start creating immediately. So for us, it makes perfect sense. Digital manufacturing, we're a digital generation. We already have the foundational skill sets. We know how to operate computers, we know how to use the internet. So that's why it's not going away, is that all these manufacturing technologies rely on those skill sets, and we all have them. Hundreds of millions of Americans have the basic skill set that is required to 3D print or to laser cut or to manufacture your own stuff. Because in the digital manufacturing industry, everything starts on a computer. So that's the idea there.
Yeah, and then kind of to that point, millennials are going to become one of the biggest sort of mover and shaker. They're using different platforms now in order to actually design on. Like mobile technology is getting really big in the design area, where designers are taking this with them when they're leaving their studios, and they're actually able to, design fairly well on a mobile platform, which is definitely, of course, the future.
Hey, one other note about that, Dan, do you mind going back up to the couple other slides before? So, who here works with Adobe? Or like some sort of, are you a designer? No, you just work on Adobe? Okay. Yeah, so Adobe, but everybody's familiar with Adobe, right? Or you do graphic design, flyers, or Photoshop, or you do film editing. So this is Adobe, this is just a screen grab, random screen grab from Adobe Illustrator, which we use every day. And then Dan, if you just pop down to the next screen, which is three-dimensional editing software. That's what I mean. We're all digital. These skill sets translate directly. What I was thinking about this morning when I knew we were coming in here to talk was film, because we have a film background, and what happened when, way back when you're actually literally cutting 35 millimeter film and splicing it together when you're editing a movie, and then all of a sudden these Avid systems showed up, and you had to learn a completely new process from the ground up if you were a film editor and wanted to keep your job. It's not the same right now. We're not asking people to learn a whole new skill set from the ground up in order to access this technology. In fact, we're trying to, no, actually it's the same skill set. It's really similar. Just the learning curve is going to be really quick for us digital natives in our generation. So I wanted to show you the design interfaces. They're essentially the same thing. They're very, very similar.
Yeah, and to that point, we have a lot of clients who come to us without having any sort of design background at all. They just maybe know how to draw, right on Adobe Illustrator, and then they get a hold of Onshape or ZBrush, and within a matter of weeks, they're turning out full-size dolls, right, that have appendages and everything. So the learning curve is relatively short. It just takes a couple hard weeks probably sitting on a computer. Well,
actually, I just thought of, was anybody in here for the previous talk, for the voice recognition? We came towards the end and they were talking about this simple idea where the computers are dumb in lots of ways. They don't know what to do with all the data and information and power we give them. They need a command, they need a human behind it. So talk about 3D hubs and these types of websites where it's drag and drop your 3D file and it'll end up in the mail tomorrow sort of experiences. They're completely missing out on the fact that these 3D printers don't, or digital manufacturing machines, they don't know what to do. It requires a human to tell them what to do, a human to design something, a human to come up with an idea and then send it to the machines. So they're only going to do as much as the human power behind them. And us as a company, like, we really are tapping into that because we're not engineers. Like, we get the hardware, but the hardware, that'll continue to innovate. We'll talk a little bit more about that in a bit, but it really requires the creativity of human beings in order to really turn this technology on. So anyway, so maybe.
And then to that point, like, what are we doing with this technology? I have our website kind of photo up here. This is our case studies page. And we add to this at least once a week a new case study that fits into our target market. Our target market at 3D Brooklyn are artists, entrepreneurs, and agencies. We focus on people artists and entrepreneurs who don't know anything about 3D printing, but know that they want to make something, right? We've had some pretty awesome projects that I wanted to cover if we could, if it's not too boring. The most recent one was a medical one. We 3D printed, actually, just to kind of start, this is the inner ear. This is inside here. It was 3D scanned with a MRI, right? And then 3D printed and adjusted. We kind of adjusted the design and everything. You guys can take a look at it. So why did we do this project? First, the design and the scan was open source. The woman who came to us had no design experience and didn't really know anything about 3D printing, but she wanted to get the word out about this being an actual educational tool. So what that is it shows people, they put a couple rings on it, and they show people how they can rotate their head in order to get rid of vertigo, to relieve vertigo. So
there's actually a whole system of postures, just like, it's pretty complex, like, to begin with. So you have to get your inner ear in certain positions to move crystals through that organ in order to stop your vertigo. So it helps people at home where they have this little device, and we're developing the next generation for them. It's going to have liquid and bearings on the inside. But yeah, it's a direct medical application. Right?
yeah, go ahead.
Yeah. Yeah, it's a good question. Yeah, that is a current application, like today, that they're doing that, and they're doing it with like plastic prints also, because just being able to see the scale of your patient's heart, like even if it's in plastic, is hugely valuable for surgeons, ahead of time. So there's going to be a lot of advancements in the medical space using additive manufacturing, but even today with plastic $20 prints, they still have a huge advantage. I mean, 30 minutes less under the knife in the operating room is really going to increase a patient's chances. So yeah, this is an example of sort of what you don't often think of. It's like an entrepreneurial medical device, right? She's a doctor, and she had this need for her patients to explain to them how to go through these moves in order to help them. And she came up with this idea and developed it using 3D printing, and is now selling it and adding to her revenue as a doctor. And she has her own. Where's she in North Carolina? Yeah, she has a small practice in North Carolina, and now she's offering products to her clients, which is super interesting, today, which is what we like to focus on, like what's possible today. We can all talk about what may be possible, but we're aware we don't want to overhype it again. We were there for that, so it's not about overhyping, it's about explaining what's possible today and where it's all going, and explaining that if you get in today and you start to pick up these skill sets and understand what's happening, you're going to be in a good position tomorrow, whatever comes at you.
Yeah, and then on that point, like, we have this example here, and this is who's using it today, which is your dentists, right? So you can go and get a crown made within a couple of hours now, right? And that's already being done at dentist offices. They're doing everything internally. And they're expanding their business by just adding a couple more hours to the whole experience. Instead of waiting, I think when I got mine done a couple of years ago, it was like 2 weeks I had to wait for mine to come back. So the medical application of it, the instantaneous side of it's happening, and it's definitely going to get more exciting as the materials come out. Just a couple other ones really quick. We did an IoT one. This is just kind of fun. It's like a New York City train sign, sort of. Actually, you speak on this one probably the best at this point.
Yeah. So, we keep our website fun and our whole culture fun, but really what we're talking about here is impacting the medical industry, like coming to market with an IoT device in Bushwick in 2017. There's actually 20 or 25 of these. You want to click on the train sign thing? Of these devices around New York, and it's really simple. It's using a Raspberry Pi, connecting to the local Wi-Fi in a bar or restaurant, and pulling down MTA data. So when you go underground and you see when the next train's coming, it's the same data. It's real time. It's being pushed to bars and restaurants. There's lots of places this can go. This was one of our clients' projects. He's now raising money for, but it's an IoT device. It is connected to the internet, and it's popping up all over Bushwick, mainly Bushwick right now, but also we have a few in the city. But it just goes to show you, like, anybody can actually leverage this technology and start introducing these things. And collectively, like, very core to our mission is that we understand that it's going to take all of us. It's going to take a village to really pull the value from these technologies. It can't just stay in the hands of large companies like 3D Systems or Stratasys. They're doing their thing. It can't just stay in research labs or be in these like niche groups of engineers and industrial designers coming out of university. It has to become popularized, and then you'll start to see all these different things, entering our society. This is another example. So medical IoT device. This is solar. This is a solar lamp that was developed using 3D printing by another client of ours who started his company based on that premise, combining solar with light, and like low run manufacturing. So he's doing essentially collections. He just had a successful Kickstarter with this product, but this is a solar lamp, and Corey, who's the name of our client here, can iterate on this design faster than the biggest companies in the world, and he has throughout this whole process. And he's paying much less to do it. He's not tooling up and injection molding prototypes in the tens of thousands or hundreds of thousands of dollars. In the course of 6 months, he's iterated over and over and over on this product, and will continue to do so because he's not looking to jump from 3D printing. He's looking to use 3D printing to make him powerful. So he doesn't have to come up with capital to pay for tooling anymore. No, he's just going to sell out of this version, update it, sell out of the next version, update it. So when solar sells, yes, yeah, question.
Production phase? Is this more for prototyping, or is it more for a continuous production and delivering?
Sure. Yeah, the train sign was prototyping the frame, right? So that was an Indiegogo campaign that our client came to us with. He's like, hey, I sold all these things, but they don't have cases. Can you help us? Low run production, design, prototyping, low run production. Corey but eventually train signs will be injection molded. Corey is different, where he sees 3D printing as a big advantage. It allows him to continually iterate and come out with new products super fast. So he owns his own 3D printers now. So he started with us. We printed maybe like 30 to 40 like small lamps that he designed himself. And then once he got to a certain number of units sold, he put that money right into a 3D printer, and then started printing larger scale pieces, higher margin pieces. So he has 3D printers now and is making money as an early stage entrepreneur, and didn't require very much capital. I think maybe his 2 machines combined were like $6,000. But to tool that product would be hundreds of thousands of dollars.
Yeah, and even just a note, after his Kickstarter, he's been iterating on it more and more before he sends them out. So he's actually improved the design and the circuitry within it over that period of time. So the 3D printer has allowed him to kind of not feel stuck after a Kickstarter has been funded, right? Which I think a lot of people fall into.
Rapid prototyping too, because he's been rapidly prototyping his electronics with pick and place machines and other groups. We don't do that. We do 3D modeling and 3D printing mainly. But he's been executing in the same entrepreneurial and like design avenue with us 3D printing, but also like iterating on his boards, 100 times over in a few months for very low cost,
So you guys were providing a service for modeling and for printing, and he was like more the designer.
Yeah, exactly. But as is the case with lots of our artist clients, especially, Corey's an artist entrepreneur. He picked up 3D modeling himself, and now he just sends us files or has us do updates or take a look at it, because we know what we're talking about with 3D printing. We can definitely help people solve problems and help them with the learning curve. So But that's exactly what we want. Like, we want Corey to spin out and start his company after prototyping with us, you know. Same thing with Tim with the train signs, or Joshua with his dolls. Like, all of these clients are coming through, and the more entrepreneurial ones, the more passionate ones are spinning out and starting businesses and buying their own machines, you know, or leveraging websites like 3D Hubs, you know.
And I guess that's a good point to kind of bring up too. Like, a lot of these people start as clients and then they become like partners, right? Can't tell you how many people we've worked with who didn't know anything are now an expert in something that we're not, right? And then that's expanding our business further at that point, because then connections and the community keep growing year by year, right? Just a couple more really quick. We did a really kind of drone thing for a company where we created a martini shaker, right? Or like a shake, we called it Shaken Not Stirred, with expert drones. All it did was like fly up, shake the drink, and then go and deliver it to someone. But we custom made everything, kind of a fun project. The drone stuff, outside of the drinking, is actually like pretty crazy, because you can create anything customized for a drone. You can even rip all the parts out of it and re-put it into a whole nother configuration. So limitless, really there.
And that was done in about, I think, a week, maybe a week and a half, from concept to delivery. And they had to take it out and fly it over people in that timeline. So, but that's how fast it can happen.
We did a full season with the Vikings 3D Prophecy show, where they had props created from the show. Nate went out and scanned them with our laser scanners, and then we came back and actually created them in full size, right? And then we gave all of those away, those designs away, to the fans of the show to go and print for themselves. So some of them in this season were like swords, bow and arrows, crown and scepters, rings, which were by far the most popular. You know, ravens, snakes, all kinds of stuff. This was a pretty popular campaign, had millions of views. Downloads was kind of small because we're talking about a pretty niche market for people downloading and printing, but they definitely kind of did a lot of the social marketing and media for them. When they had to print it, they would sit there and share it, right, immediately. Let's see if there's some interesting ones here. New York International Auto Show. Oh, this was the artist I mentioned earlier who came to us and had no idea how to do 3D modeling. And that's what he did after 2 weeks, all right? So he already had a little bit of a doll background, right, making dolls, but then once he got the 3D modeling software, he just started running with it completely. And he works with us quite often now.
Yeah, he used to sculpt traditionally, like in clay, and then fire it, you know, porcelain doll maker. So that skill set translated directly for him to a digital, you know, CAD environment.
And then I'm gonna skip the recycling stuff right now. We're gonna move on. All right, so real quick, does anybody have any sort of questions at this point? Yeah?
So I wonder how complicated is it to model a 3D model? Is it like, or what is the typical learning curve in terms of time until I'm able to put out my creativity in the system? Are there like already existing components that I can use for standardization, modularization? Or how is it usually?
I mean, it depends on what you're designing, you know, and it depends on how you think about design. You know, so on one end of the design spectrum, you have somebody like Joshua who's sculpting in a digital workspace. You know, so they're pushing and pulling on material. Those softwares today, or really like yesterday, were made for animators, and now they're introducing all these plugins and things so you can actually send things to 3D printers. So software is innovating on top of itself. But to me, that, like, I'll never be good at that. You know, I will never be. We had a subcontractor designer do like remember Chris Christie was on the beach on 4th of July sitting there when he told nobody to go to the beach, or like close the beaches, that meme. So we had a client come to us, and we sent it to one of our like freelance designers, and he came back with like this awful Chris Christie model, right? Awful. It was absolutely awful, which happens, you know. But I was looking at him like, that's exactly how mine would look like if I tried to go after it. But on the other side, I'm like really mathematical. So if I'm working with shapes and thinking about geometry and things like that, have picked up those skill sets really quickly. But like I like to tell, or like when clients ask about pricing, like how much does it cost? So that's the people walk out of 3D Brooklyn, and for I think the lowest price is $23.75, which is 15 minutes of design work, and it includes your first plastic prototype. So people will come in with an idea, and if it's really easy, like lots of I think like 99-cent store things, you know, like plastic parts for hooks, and people will come in and be like, hey, I just need these two parts together, and be like, all right, cool, that'd be $23.75, and you know, you can come back and pick up your part later today or tomorrow, you know, so that's the low end. You know, so you can work with a vector, like think a logo, right? Oh, I just need a logo on the door of my office. The logo file, you just click and drag and send it to the printer, basically, so really fast. Dolls, not so much. You know, that learning curve's, you know, pretty intense. If you go to like industrial design level, like we have a good friend in the neighborhood who designs vending machines, like that's a whole nother level, you know. But product design for 3D printing, I believe that anybody can pick that up. And then, you know, once you have made 10, 20 things, you'll have most of the skill sets figured out.
Yeah, it's kind of the same thing, like everyone's a photographer, right? Everyone's going to be a designer in a matter of 5 years, right? You'll be able to design things. You'll be designing things because software will get better, and you'll be able to just kind of tell it to do certain things, right? Or software is going to actually give you like 1,000 choices, and you're going to just filter what you want at that point, right? So the idea on the technical design, it's kind of similar to what you were saying about editing software, actually. Like editing software got super complicated, and then now it's like really easy, right? And there's all these plugins and everything for it.
Now Google delivers edits for you based on your weekend's videos you took at the beach. You get a message, be like, here's the edit from your party this weekend, right? You don't even have to do anything, and you just have to show up and point your camera, then you get an edited, you know, video. It's insane. There's actually an app. Everybody's familiar with Autodesk. Okay, so Autodesk is trying to tap into this what Dan was just mentioning. So they're developing this software where you just give it parameters, right? So you're like, the example in the article I was reading was talking about a chair. Right, all of us in this room, when I say, hey, imagine a chair in your head, all our imaginations are all like right here in like this little circle. So Autodesk is building an app where you would put in parameters like, hey, I need it to be between 18 inches and 32 inches off the ground and support, you know, up to 100 pounds or 200 pounds in weight, go. And then the software results just fly in, you know, so you'll have 10,000 options that the computer is making for what the basic function that a chair needs to provide. So it's like, software innovation, hardware innovation is coming. Imagine that. It's being able to be like, well, Alexa, give me a chair design. I need it red. I need it to look like a tree. Eventually be made out of wood using digital manufacturing under $1,000 and delivered in 2 weeks. And they're like, cool, here's your 12 options. That might be a little stretch. That might take 10 years instead of Dan's 5.
But it is the design side of it. I saw a couple of years ago as being like, everyone wants to be like a designer. Everyone wants to be an influencer, right? But design is a very powerful tool, right? And it only takes having a style that makes you stand out, right? So my style to design is actually completely backwards. Mine is to actually take two different objects and then smash them together and then make them into things that I want, or steal off of things, like cut stuff off. Definitely not the right way to design, right? Because there's weaknesses and everything, but it's fun, it's fast, it's quick. It's the way that I kind of make things.
By the way, if you pay us for design services, him and I aren't doing the work.
Yeah, we're not doing it.
Our other founder is, or somebody on the design team.
What in your opinion is currently the most intuitive, let's say, 3D design software? Because, you know, if you imagine on that line, like, just like how, for example, designing on 2D has evolved to even, let's say, Microsoft Surface, where you could, like, literally draw, you know, or simple that's in. So if you imagine that, and if you take that into the 3D sphere, maybe in a few years you'll be able to, like, literally just put on a camera hold and literally sculpts with your hands and that way you can just a lot more intuitive.
There's an app for that.
Yeah.
Yeah, the HTC system with the
Yeah.
joysticks. There's one app that does that now, and you can export for 3D printing. But it's like, they're blobs. Yeah.
Like right now, if we wanted to learn to play around with something, what do you recommend is the most?
Just getting started.
With some design or some Adobe knowledge.
Okay.
Yeah.
There's a lot.
I like rhinoceros, right? So the cool thing about that is that once you learn your terms, you can just type it as you're modeling. Be like extrude, displace, and it'll pull up all the different functions. So it's really user-friendly and intuitive like that. So if you know the word for the action you're trying to do, just type it and you could execute or figure it out. The new one we're using and just moving everybody onto is Onshape, because Onshape's connecting the cloud. So Onshape, yeah, it's cloud-based 3D design software made by the guys who founded SolidWorks.
It's this one right here.
So SolidWorks, does everybody know SolidWorks? Yeah, it's industrial design software. It's what our friend who designs vending machines uses to design those complex products, So Onshape is what we now use to teach high schoolers about CAD design, get them in the door, and you can share a lot. It's really, really user-friendly. Work on the same design from other cities on the planet if you want, like real time.
It's great for education because it's free, like you said. So, and then I was going to just mention on that point, the mobile technology. It may be a couple years off, but I definitely think getting used to modeling on a mobile platform is probably ahead of the time, right? Sitting on a desktop and doing it like that, I don't think it's going to be the future. So that's why I would stay away from any sort of desktop applications. Look at whoever's charging into mobile, stay there.
We've been talking a lot about modeling though too. We don't think that everybody needs to learn how to 3D model. We're not trying to say that, Actually, quite the contrary. We're in business because we sell modeling hours to other people. We've built our business because we understand that 99% of people will never 3D model for themselves ever. It doesn't matter how intuitive it gets or how easy it gets. I think about how to build a website, right? Like Wix. It doesn't matter how easy or when was the last time I built my own website? I don't know. It's been years. So, it's people behave how people behave. So most people would rather pay somebody else to design it. Or not do something custom, or society will figure it out, So you don't need to learn how to design, but you need to understand how all these systems work together, so you can start to use the technology. So if you're going to start a small business or something, you need to understand these things so you can introduce a market or a product to New York. You don't necessarily need to learn how to 3D design for yourself, But if you don't understand that the more and more products you buy off of shelves from New York stores are being designed and manufactured here in New York, starting on computers, then you're going to be left in the dust in lots of ways. You're going to be light years behind other people who are staying on top of these technologies.
Cool. Any other questions real quick? Because I want to move on to jobs and economy. You want to start with this one a little bit?
Sure.
It's kind of just getting back into the...
Yeah. So, we were talking a second ago, what I was talking about earlier was trying to make the case that it's not just hype. Like, what's different now than 3 or 4 years ago when it was super popular? And one of the things we were just talking about is software and hardware innovation. It's not a hard sell. We all know that this stuff is getting better, and it's getting better at a faster rate. We're living in an age of acceleration, right? So for us, it's not about we're not a software company, we're not a hardware company. We're a social company. So we need to innovate on a social level, which is why, as Dan started the day, he was talking about why we're in Bushwick and not in Soho or Midtown. We're in New York, but we're really trying to connect the dots and create value for people who live in our neighborhood in Bushwick. We're thinking socially, right? So part of that is what we're talking about is job innovation, right? So we had talked earlier about the idea that we're all digital natives, right? So that's number one. We all have these skill sets, so we're all going to start applying them more and more of us are going to start applying them. The second one is the hardware and software innovation is not slowing down, it's getting faster. And the third one is that there's actually an economy, right? There's economic benefits. There are jobs being created, and there's businesses that are starting that need to hire people with these skill sets. Right, so this is a stat from this guy Ed Hackett, who's one of the leaders in additive manufacturing education at the university level in the U.S. So he put out a white paper a year or two ago, and basically he surveyed all these recent engineering grads and asked them what they were interviewed about for their first jobs out of college. And 38% of them, the number one skill set that was required by their potential employer was additive manufacturing. 38%. Of new engineering graduates are asked whether or not they know about additive, right? there are jobs. We're not, we're a small startup. We're hiring people. We're hiring engineers and designers. So there is a market for this. It's not that exists today, and it's going in the right direction. The other side of the coin is that it's also becoming popular again. Like being an engineer or a designer is freaking cool. Like it's cool. Like, and all these other institutions are popping up, like Girls Who Code. It's cool to code. So it's not only that jobs are coming up, but these jobs are cool jobs again. It's like space race, like we were talking about earlier this morning. So there is an economy. There are jobs out there for these skill sets. All you have to do is pick them up.
That's fine. And then we were just kind of showing like Neil deGrasse Tyson, like these sort of icons are of nerdiness are getting
Bill
very
Nye,
big, right?
yeah.
Bill Nye, everybody. So we're hitting pop culture
Elon.
with science and technology, right? And then why will 3D printing work this time, right? So a couple of years ago we saw it get really hyped, it got shut down. Now it's actually going to work. Why? Well, you have platforms, which is that one right there that I sent to you guys, Formlabs. That's that resin print. It's a superior technology, right? They did a very good job bringing it to market, and they've stayed with that technology and platform.
Here's some example of resin eyeglasses that we're making here in Brooklyn. Oh, okay.
So we've had these printers for a couple of years and have been iterating with them, and kind of what you're seeing here, they have opened up to many different materials, right, which is fantastic because that's where it goes into the dental and medical side of things. But on top of that, we're starting to see the hardware sort of acceleration happen to where this technology is now going to be put into a cell, is what they're calling it. I don't know if anybody's heard of this yet, but basically it's an arm that changes your prints and washes them and cures them automatically for you for about, I think it's 20 grand for the whole thing or something, or maybe it's like 50 or something altogether with them.
Yeah, they're all custom built. But why this is important, this is a good example because this machine replaces labor costs in the market, right? So if you're running a 3D printer service and you have a half a dozen of these machines, you're gonna have to pay a couple people all day long to sit there and run the machines and pull the parts off and clean them and cure them and all of that. This machine takes all those costs away from you as a business owner. So now you're able to expand your business, offer new services. So economic growth is like accelerating behind these hardware innovations like the form cell.
Yeah, and that job doing that is kind of messy and not really that fun. So a robot is much better to do it, honestly. You're not taking away a job that someone really wants to do because it's not that glamorous. This is the sort of, I had a GIF for this, it shows it in the video, but this is just how the interface works from your laptop. It's very efficient. And then Formlabs just came out with a pretty game-changing technology, which is the SLS technology. Do we have any SLS here or no?
Yeah, I have this guy.
Oh, okay.
I've been playing with. You guys want to see that?
So it's really small,
helicopter.
but SLS is your powdered nylon, which you don't need any of the supports that you see here. Or actually, you don't have any supports there. Sorry. You basically can print it just like you see here. It comes right out of the bed, right? Also, SLS technology is the most efficient and most cost-effective because you can actually fill up the whole bed full of whatever you need to print, right? You don't have to waste any room. So what that means is Formlabs focused on the mass manufacturing side, right? The idea that you could create a bunch of washers, maybe 20,000 of them in one run, right? And that could be a component that you use in one of your parts that you're actually sending out in production. So these two technologies make me pretty confident that 3D printing is going to really catch this time and start to really grow fast. And it's because also that this printer right here is only about 20 grand. And that sits on a table like this. It's like a small refrigerator.
It's actually 10 grand.
It's 10 grand? And the same
Yeah,
thing as the
but
other
yeah, they have
10
the
grand.
other machines like the cleaning machine and the material recycling machine.
Yeah, this looks really like simple. There's actually another unit that goes with this that you have to actually clean all the parts with. But it's relatively small sort of space that it takes up.
Well, what's important to understand about what Formlabs is doing also, they're a millennial company. They're founded by a couple MIT dropouts, obviously. Right? engineers. But what they're doing is they're just introducing these technologies at an affordable price point. These technologies were all invented in the 80s. So the patents are starting to expire. The plastic, like what this apple is, that expired in 2013. So 4 years ago. Now you have Enable, who's a company who's distributing prosthetic hands all over the world. That's happened on top of a technology that's really only been available to consumers for 4 years. And now we're distributing prosthetics all over the world to kids. I mean, so what Formlabs is doing is they're right at the tip of the sword, coming out with the new technologies faster than every other company. Nobody's keeping up with them, not even the big boys. You know, the big boys are busy making money from Boeing and Lockheed Martin and all these other companies because they've been doing that for 30 years. Why would they change their model? So it's the new guns who see an opportunity in mass market. In their case, engineers, they're very engineering focused, but we're not engineers and we're consumers of their machines, you know? So that's only gonna get faster. You know, the metal patent's gonna expire. These guys will come out with a desktop metal printer for under $5,000, $10,000. And now who's gonna enter the market? Now what business opportunities are there for entrepreneurs, artists? You know, it's gonna happen faster and faster and faster and faster, yeah.
Does that mean that the reason why it's up till now still not like possible to do actual metal is just because of the patent, or
Part of it has to do with that, but you also can't, right, it's going to take development, right? You need to, you know, companies need to have access to certain features because these are sets of patents, you know, there's not like one patent, there's hundreds of different patents underneath, like direct metal printing, for example. But no, it's, you know, it's a combination of everything. You know, where's the market for metal parts? It's not really there yet. You know, there's a pretty big market for plastic parts. So people are developing plastic machines. But yeah, so yeah, as the patents start to release, you'll start to see other groups. And in the meantime, groups are going around it as well, right? So Formlabs got into a lawsuit with 3D Systems, who now I think is taking 10% of their gross forever now or something over the laser mechanism for the resin machine. Right, so Form tried to go around it and develop their own platform because that patent was still underneath 3D Systems. They got sued for it. Speaking about social innovation, what we're talking about is this idea that hardware and software is innovating already. There's a ton of groups out there in the space who are making cooler machines, especially for manufacturing, and you know, cooler software for manufacturing. But that really what we need to happen is for us to innovate as rapidly in our neighborhoods and in our communities. So that's what social innovation is that it doesn't matter how powerful this technology gets, if people in our community don't know how to access it, if they don't have the skills to use the machine, then we're all going to be worse off. So we need to, as a culture, start to innovate as fast as technology is changing. The first version of this, they didn't lean back on a wall. They just stuck out horizontally so the wind would come by and blow out the glass bottle and explode them all over the street. So doing the complete opposite of what we were trying to do. But in the end, we ended up with something that was really cool and really inspired people. Now, how we do it is we basically have businesses sponsor them for $100, and the proceeds go to Sure We Can, one of the groups who was involved in the project to begin with. So the success of that campaign really inspired us around 3D printing and the whole social impact potential for 3D printing. And as entrepreneurs, we got really curious, and that was 4 years ago now. So we've tried everything under the sun in terms of business models, like from like recycling our own potato chip bag material and 3D printing with potato chip bags.
So the key part to this is this plastic is recyclable, or what is actually the right term for it? This
is compostable.
Correct.
This is bioplastic,
this is
so it's
PLA.
made from corn here in the
so
US.
we were getting a lot of questions like, why don't you make them out of aluminum? Why don't you make it out of this? And we were like, aluminums doesn't seem like it'd be that easy to make these, but they were compostable plastic, right? So that was kind of leading us down the recycling angle, and then we got into actually doing our own filament and into the materials that are widely available from the waste streams, right?
Right, because you know we saw that our recycle bins were getting filled with plastic, and they're made out of plastic. We're like, hold on, there's one more dot to connect here. Why can't we make the recycle bins out of the bottles that people are putting in there, or at least out of the material, the recycled material? So a couple years later, we were able to do that. We have some urban hubs on the ground there made out of recycled PET, which is what this plastic bottle is made from. But it took a couple of years of curiosity and R&D. So one of the first raw materials we were able to get our hands on were recycled potato chip bags. Magic. So we started buying all these desktop hardware that allowed us to grind down plastics and melt down plastics and turn it back into 3D printer material. We bought a machine that we thought would be a different type of 3D printer that we thought would help more, and eventually we started to print stuff and we were successful. So here's an example. So this is a bioplastic, it's a wall planter, right? So made out of bioplastic. This is an early prototype of that same design made out of potato chip bags.
Yeah. So go ahead. Sorry. So ironically, this is PPPE, polypropylene polyethylene. It's the same sort of, and this is just kind of my science nerd stuff. It's the same sort of material that's used on the waste in the space station, right? So it's kind of important that, like, when we did this project, we got a little bit of NASA sort of like coming over and asking us questions, and we all got very excited, and we thought maybe we'd be going to Mars or something, but maybe one day, right? But this project then turned into more recycled plastics that we actually sell and print in-house. Potato chip bags are very difficult to get to work on a mass scale, so we kind of had to use that as like a fun sort of project, right? Just to kind of get people excited. And this is actually a photo of the other sort of filament that we came with eventually. And then
Totally not profitable, by the way, from an entrepreneurial perspective. Like, we did it all. We put in our Malcolm Gladwell 10,000 hours figuring out how to 3D print with trash, and figured out there was zero market for it. And here's one more. Here's one more test that we did. So we're like, all right, how can we connect the dots more? Let's injection mold out of this trash. So this is a test we did trying to make here's a couple you can kind of see. So we injection molded combs out of potato chip bags and a little bit of pink to try to get a marbling effect to try to convince Kiehl's to start manufacturing product out of their industrial waste that was coming out of their packaging factories. So so how we made that was $30 in aluminum, a CNC machine, and $20 metal 3D print.
yeah,
So our tooling traditionally is one of the most expensive parts about manufacturing, paying $5, $10, $20, $50, $100,000 just for the metal mold that you inject the plastic into. We made that one for $50.
So you guys didn't 3D print that?
We didn't 3D print that. Right, we 3D modeled the mold, had a CNC engrave it. The metal, we called it a coin, but the Kiehl's logo that's inside the mold was 3D printed, direct metal print. Oh,
yeah, that's your metal
that
print
was
right
cast steel,
was it cast
actually.
steel?
Well, they printed in nylon, they burned it out, and they cast it into steel. That allowed us to get the Kiehl's logo and that detail, because plastic printers are terrible with that sort of thing. Also not profitable, doesn't make sense.
Yeah.
Ended up being like, yeah, we couldn't because our injection molding machine required a person, so we couldn't pay a person little enough to stand there to make it a profitable enterprise. So, nor did we have 20 grand lying around to buy like the next level injection molding machine. So,
yeah.
so 3D printing was cheaper.
Are you aware of any company, because I assume you deal a lot of suppliers, who makes a 3D hot bed extrusion process without a filament?
Yeah. It's like, so the pellets you're talking about.
Okay, so they go directly from the nozzle or from the pellet to the nozzle without them producing a filament in between.
I know, I read of I was actually going to show you today. There's for an FDM printer, there's a connection, so you can do that now.
Yeah.
So on the cheaper printers, you can do that. You can just add a little hopper to the top, and it'll grind it down and shove it right through.
That's hardware innovation.
Yeah.
Manifest. That's exactly. It's like, all right, so.
Well, there's a German one that's doing it on like a real scale. What I was just talking about was like 3D printing your own sort of hopper for it, right? I'll show you.
Who are the guys with the big Delta printers that do the 30-foot printers?
This is what I'm talking about. I don't remember the name.
SeeMe CNC.
Okay.
SeeMe CNC, computer numerically controlled device. SeeMe CNC. So these guys had to develop their own system. So you'll see this a lot in 3D printing also, is you'll see groups just develop their own custom machine because they want to like 3D print in carbon fiber or 3D print in cement. These guys, SeeMe CNC, built a 30-foot Delta printer, which is just one type of plastic printer. It looks like a teepee. And they were extruding at like 6 millimeter layer lines. So they couldn't use filament because they wouldn't be able to be fed fast enough. So they developed their own hopper system, and they're just dumping in like, 30 pounds of pellets at a time, and so they can extrude that fast.
Yeah.
You also see like syringe-based systems for medical applications. So you're using a liquid, As opposed to melting a thermoplastic, going from hard to liquid to solid, you'll see groups like BioBot building same type of 3D printer, but replacing the print head that drags in plastic with a syringe. BioBot, yeah, they're local. Actually, they might be Chicago. So these guys are entering the market with a $10,000 bioprinter, where they have their own synthetic cartilage material, and the idea is that you'd be able to deposit your cells on top. It would eat away. It would use the scaffolding is what the word that they use is like agar basically. So you deposit your cells, the cells eat away at the scaffolding and replace that form, and then do what cells do, which is create skin or an organ. They do like ear, like cartilage a lot. That's where they're at right now. Eventually, it'll get a lot better.
And on the pellets sort of point, I can't tell you enough how easy it is to get pellets for free. You probably could call any major corporation and get 40,000 pounds of pellets delivered to you, no problem, for free. And the reason why is that, and we've been contacted by many large corporations to take their waste and turn it into 3D printing filament, but there's kind of a problem with the sort of economics of it, right? We found that there's no market for it. On top of that, the cost of oil right now is so low, so the competition for new plastics versus recycled plastics is like done. There's no one's going to care about it. So until the price of oil goes up, like that side of the market's going to have a glut, and people are going to be holding recycled plastics in warehouses for years. I don't even know what they're going to be doing with it, to be honest. But it's very easy to get your hands on it and start working with it. Just about any material.
Yeah, and more and more groups are finding how easy it is to make bioplastics as well, right? So things, you can make bioplastic from sugar, right? So think about how many products are made locally here in New York that have sugar as a byproduct. Here's one example. So this is our beer can handle, right? We try to keep it fun. So it snaps on your tall boys. We also have a regular can size edition for anybody who's interested. And this is made out of sugar from spent grains at a brewery. These guys manufacture this in North Dakota, I think, is where they're at, right? Yeah. With local breweries, spent grains. Here, check that out. So you can make these bioplastics out of food waste. You can make, you can recycle potato chip bags, or we did it with milk jug. Like, it's all post-industrial right now, right? So imagine when we figure out processes for cleaning post-consumer waste. So has anybody been to Sims, the recycling facility in Red Hook here in New York? So Sims is really interesting. Sims is the only recycling, it's a private company. They deal with 100% of the recyclables from the 5 boroughs. So they deal with over 1,000 tons of recycled waste a day. 100 tons of PET, 100 tons of HDPE, 100 tons of polypropylene a day. And their main market for it is Atlanta, actually. Their biggest customer drives 18-wheelers up from Atlanta. You load just bales of all these plastics, mixed plastics as well, onto the back, and then drive them all the way back down to Atlanta to turn them into product, so then put them back on the trucks and drive them all the way back up to New York. So even the macro recycling system and manufacturing industry as it works here in the U.S. is still far from perfect. So we talk a lot about our vision for New York is a city where New Yorkers are designing products that are being manufactured in New York and sold in New York stores, that are being used and recycled in New York, turned back into raw material that goes back into products for New Yorkers. And we're interested in that, and we've done our fair share of R&D, and we know it's possible. Like a couple clowns like us can 3D print with potato chip bags. Imagine what the rest of us can do if we had access to the tools and were inspired to do so.
Cool.
Oh yeah, that's Sims. That's all the recycled waste. Yeah. So in the background, you have, this is a crane that's taking the waste off of a barge. So they barge down all this waste from the Bronx. And then it goes through this ginormous machine with a ton of scanners, and it's using magnets to grab metals, and it's crazy. But what it doesn't grab is bioplastic yet. So another big issue on that end of the market, the materials market, is that bioplastic is great because it's compostable, but the macro recycling systems haven't caught up yet. So if you drop bioplastic, like if you drop that wall planter, that white wall planter that's going around into your green composting bin, it's going to get sorted out and sent to a landfill. If you drop it in your recycling bin, it's going to get sorted out by the massive machine they have at Sims and get sent to a landfill. So it has a great, it's a great idea but the macro systems are having, it's going to take time for them to catch up. So it will happen now.
Cool. So we kind of talked about the age of acceleration. Kind of went over the medical stuff. Oh, just back to space. I don't know if you guys know that, but they are 3D printing in space, right? They're printing their tools and kind of figuring out how to, you know, I mean, it actually probably looks really similar to our prints right now. This is probably what they're figuring out right now. It's all got wrong layer lines and everything, but they're taking the materials that are literally on the space station and reprinting with them, right? And then from there, you know, you got the bioprinting, you've got food printing, building printing, and then of course, what's really going to happen, which is they're going to send these machines to another planet. They're going to mix together the plastics and the soil, and they're going to print their landing pads and everything else, right?
All the
So-
same basic skill sets are required to operate these machines, by the way, which is back to our original point. Like, you know, like this is the same technology, except instead of plastic, it's cement, and it's scaled up. Or instead of cement, it's chocolate. Instead of chocolate, it's synthetic cartilage. You know, but you're all using the same types of programs to get there. So,
And we were experimenting with that. We were taking soil and this material, putting it through a machine and 3D printing a structure similar to what you're seeing here. It's very, very, very fun to kind of see how it's all like very connected. It's not like super far away, right? Which is kind of brings it back to the jobs and the economy, because the youth are going to see this and they're going to grab it. They're going to focus on the mobile technology, and they're going to pretty much build these platforms for us, right?
we're getting the hook from the. Is there
Yeah.
any more questions before we wrap up? I think we're over time. Yeah.
I have one question in terms of company. How many people working?
With us? 7.
And what was the proportion between social projects and commercial projects?
About 80-20. We try to follow the 80-20 rule as much as we can, you know. But we are bootstrapped, you know. We haven't taken any investment yet or anything like that, so we do tend to focus a ton of our time on like our clients' projects, you know. So a ton of inventor entrepreneurs is our biggest market. Artists as well, and then small businesses. So we spend 80 to 90% of our time working on those projects, and the rest of the time making beer can handles and things like that, putting up recycle bins in the neighborhood. Any other questions? All right, great. Well, thanks for listening
guys.
to us.
Appreciate you
guys.
listening to us.